How's it going, Calc kids? This is it. This is the video in which I give you the shortcut to derivatives. Okay, rules for differentiation. Well, let's look at the first one. All the rules are noteworthy. Okay? So the first rule says the derivative of a constant function, if f is a function with a constant value c, then your derivative of c is 0. Okay? For example, if your function is 5, okay, it looks like a graph like this, obviously your slope is going to be 0. You aren't going up anyway. So when you take your derivative, your f prime of x is going to be 0. Constants are always 0. Your derivative of a million is 0. It's just a straight line. It doesn't go up at all. Okay? Derivative of every constant is the 0 function. The 0 function. And derivative of 0 is 0. Anyway. Power rule for positive power integers of x. Okay, what the power rule says is this. If you have x to some power, you take the power, you move in front, and you subtract 1 from it. Okay? AKA, if y equals x squared, y prime is you move the 2 out in front, 2x to the 2 minus 1, which is just 2x. Okay? If your y equals x to the 4th, your y prime is, bring that 4 out in front, you go 4 minus 1, which is 4x to the 3rd. Much easier. Let's do one more example. This one's important. Make sure that you write these examples down, guys. The examples are the whole reason why we come here. Let's say y equals 1 over x squared, and we want to find the derivative. Well, can I rewrite this as x to the negative 2? No. So your y prime, you bring down the negative 2, x, negative 2 minus 1, negative 3. Why didn't you show us this earlier, Mr. Terwilliger? And I can't. It's like it's a rule. It's a rule. Hold on a second. See, at one time all math teachers got together and said, we can't give them the shortcut till they can do it the wrong way because we had to do it the wrong way too. It's like hazing almost, but not really. Rule 3, the constant multiple rule. What that says, if you have a constant in front of your function, you can pull that out before you take the derivative of that function. For example, if y equals 4 times x to the 8th, y prime equals, so you can pull this 4 out in front. Put the 8 in front, x to the 7th, subtract 1 from your exponent. 4 times 8 is 32, x to the 7th. Okay, so basically it's combining, taking the last rule and just saying if you're multiplying your x by something already, you just multiply your derivative by it. Okay? Adding and subtracting. This basically says is if you're adding two functions together, you can just take the derivative of each and then add them together. You can just break them up. No special fancy things you have to do. It works for subtraction as well. For example, if y equals 4x squared minus x to the first power, because that's what x is, right? X is just x to the first power. And then y prime is, well, we can take them each and do them piece by piece. So we get the 2 out in front, 2 times 4 is 8x to the first minus, bring the 1 out in front, x to the 0, because 1 minus 1 is 0, so that just goes away, because that's 1, so it's 8x minus 1, okay? So let's put our knowledge to the test. Okay, we're gonna differentiate this whole thing. Got roll up your sleeves, loosen up, keep a neutral spine. So you do each piece individually, right? So the derivative of x to the fourth is 4x, bring the 4 out in front. 4 minus 1 is 3, plus, move the 2 out in front. 2 times 2 is 4. 2 minus 1 is 1, so 4x. Minus, you have a 1, bring the 1 in front, so that doesn't change, still negative 3/4. Now 1 minus 1 is 0, that x is going to go away. Derivative of negative 19 is 0. So there it is. And there it is. The easy way to do derivatives. Okay, one more thing I want to talk about before we move on. It's, does this curve have horizontal tangents? Okay, what does it mean to have a horizontal tangent? It means if I were to draw the graph, there's a point where the tangent line is a horizontal line. Okay, what is your slope of a horizontal line? That means your slope is going to be equal 0. So that means where does your derivative equal 0? Because that your derivative gives you the slope. Okay, so if you get a question, where's your horizontal tangents? What you need to do is find derivative, set it equal to 0, solve, and that will give you the points where you have a horizontal tangent. This one actually is 2, right? Yeah. So first we have to find y prime, which we know how to do very easily now. Move the 4 in front, 4x to the third, because 4 minus 1 is 3. Move the 2 out in front. 2 times negative 8, negative 16x. 2 minus 1 is 1. And remember, the 2 just goes away. Derivative of 2 is 0. Okay? Second, set y prime equal to 0. So we say 4x to the third minus 16x equals 0. Okay? In third, we just gotta solve it. Okay? So first I'm going to factor out x. Actually, I'm going to factor out 4x, right? So I get x squared minus 4 equals 0. You remember that handy rule? A squared minus b squared means it separates out into a plus b times a minus b. So we got ourselves, what's the square root of x squared? Well, x. What's square root of 4? 2. So our zeros are, or x equals 0, 2, negative 2. Which is also where we have our horizontal tangents. Because we get a horizontal tangent whenever our derivative equals 0. That's where we're going to end it, guys. Enjoy. You have the shortcut.